Hey there, this is Mr. Alexander, and I want to talk to you about this Unit 11 test review. I just want to go through and solve a bunch of these problems for you, and I'm just going to start from number 1 here. So some company bought a scanner for $800 and it is expected to depreciate at a rate of 10% per year. What will the value of the scanner be in 2 years? Well, I've got my handy dandy formula sheet here. And when we're talking about depreciation, we're talking about the compound interest formula. Or you could use this exponential growth and decay, because it's actually the same formula. But I'm going to go ahead and use this compound interest formula to solve it. So we're trying to figure out the value of the scanner in 2 years, which means we don't know the final amount. So my answer is going to have an A in it right there. And the P of the formula, this is the principal, what it started at is $800. And since it's depreciation, I'm going to do 1 minus. And it's depreciating at a rate of 10% per year, which means I need to subtract off 10 divided by 100, or 0.1. And I'm going to raise it to the power of 2, because for 2 years. So this, at this point, is just calculator work, and let me show you how to plug that in the calculator. So I've got a calculator here, and I'm going to type in 800 times 1 minus 0.1, and I'm going to raise that to the second power for 2 years. And when I do that, I get $648. Now you might be asking me, well, Mr. Alexander, you didn't put the n, either of the n's in there. Well, it said per year, so the number of times of compounding was 1, so I was dividing by 1 and multiplying by 1. That's why I didn't write those in, because it would have had the same effect of just not including those ones at all. Alright, so when it's just annual, you don't need to worry about the n's. Write the expression as a single logarithm, number 2 here. Remember that if the bases are the same, then you can make them into one logarithm. In this case, it's subtraction, so we're going to go ahead and change that to division. So I'm going to make that log base 3 of 63 divided by 9. Subtraction becomes addition. And I can simplify that, division, subtraction becomes division. I'm sorry. Getting ahead of myself. We can simplify that a little bit more by dividing that, making this log base 3 of 7. Next up is number 3 here. It's another word problem. Jimmy invests $2,000 in an account with 5% interest, making no other deposits or withdrawals. What will Jimmy's account balance be 10 years if the interest is compounded 4 times each year? So I'm going to use this compound interest formula one more time. And I still don't know the A. I'm trying to figure out the final amount. The principal, what he started with, is 2,000. And it's compounding, so it's going to be 1 plus. The interest rate divided by 100 is 0.05. And it's compounded 4 times each year, so I'm going to divide that by 4. And then up here I'm going to do that same 4 times, it's going to be 10 years. So this is another calculator work question. So let me show you how to type all that into the calculator. Let's see, 2,000 times 1 plus 0.05 divided by 4, close the parentheses twice, to the power of 4 times 10. And when I do that, I get about $3,287.24. $3,287.24 when you do that. Okay. In the year 2000, the population of Mexico was about 100 million, and it was growing by 1.53% per year. At this growth rate, the function f of x equals 100, blah, 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 gives us the population of millions, x years after the year 2000. Using this model, in what year would the population reach 1.6 million? Round your answer to the nearest year. There's a fancy way to do this with logarithms and rewriting the base, but for the sake of time, and the way I would do it on the test is, if I already have the function, I'm just going to type it into y equals 100 times 1.0153 to the x power. And now I'm going to go to the table and see when it crosses 106 the first time. And it does 4 years into it. We're going to round to the nearest year, so it's after 4 years. So it happens in year 4, but we started at the year 2000, so this is going to happen in 2004. And I just got that from looking at the table, the first time it passed 106 million, which is right there at year 4, 4 years after the year 2000. Another word problem here. A radioactive isotope has a half-life of 11 hours. Find the amount of the isotope left from a 120 milligram sample after 55 hours. If necessary, round the answer to the nearest thousandth. So I'm going to use this half-life formula here. And I know the initial amount, but I don't know the remaining amount. So I'm going to have A equals the starting amount, which is 120 milligrams, 1/2 for half-life, and then T for time is 11 hours, or sorry, the half-life's 11 hours, so we're going to do 55 hours, and we're going to divide that by the half-life of 11. And this is a calculator work question, so let me show you how to type that in your calculator. So I can quit 120 times 1/2, or 0.5 if you prefer, to the power of 55 divided by 11. And when I do that, I get about 3.75, but don't forget your units, which in this case is milligrams. Alright, let's talk about number 6. Write the equation in logarithmic form. So this is just that change of base formula. If you forgot, or sorry, not change of base, but just the formulas to rewrite an exponential into a logarithm. So if you've got an exponential, you can rewrite it as a logarithm, log base b, y equals x. The way I like to think about it is start with the base, which in this case is 2. So we're going to have a log base 2. And we need to take the other side of the equal sign, make that 4096. And on the equal sign, on the other side of the equal sign is your exponent, which in this case is a 12. So not really much work to show there. You just need to remember to use these two formulas right there. Okay, number 7 here. What is the asymptote for the equation y equals 2 to the power of x minus 1? I would start with the transformation. This is the parent function right here, and it's been transformed down 1. Now the asymptote for the parent function is y equals 0. And you can type that in the calculator and graph it. Let's go ahead and do that real quick, just so you can see what I'm talking about here. 2 to the power of x. When I graph that, you can see that this thing, it goes up forever, but it approaches the x-axis here and never quite touches it. So the asymptote here is y equals 0. So if the asymptote was y equals 0, and I shifted it down 1, the new asymptote is y equals negative 1. And you can actually just type that in your calculator to see it. And it's kind of hard to see, but if you type the entire equation in and hit the graph button, you can see this thing is now approaching negative 1, y equals negative 1, and never quite touches it. So that's the way I think about it. Number 9 here. Log base 27 of n, or sorry, I'm trying to solve log base 27 of n equals 1/3. So start with the base. Sorry, hey, Mr. Wilson. Want to say hi to all the folks watching at home?
Hello, everybody.
That's Mr. Wilson. He's a very good mathematician, better than I'll ever be. Now now you have it on the record. It'll be on YouTube. Now you can say it. I'm sorry. All right, so let's talk about number 8 here. Find the x or y-intercept for the equation. Y equals log base 2 of x plus 4. The transformation here is that plus 4. All right, that's supposed to be an arrow. That's going to shift it to the left 4. And let's think about the logarithmic function. Let's just graph the parent function log base 2. And you do that by doing log of x divided by log of 2. This thing crosses the x-intercept at 1, 0. Now, if I shift it to the left 4, like I am in this equation, it's going to go over 1, 2, 3, 4. It's now going to have an x-intercept at -3, 0. So that's the way I think about this. As you can't type this in the calculator and just look at it, unfortunately, but you can type the parent function in, which again, is just log of x divided by log of 2, and use some logic. So if it did cross at 1, 0, it's now going to cross at -3, 0. All right, let's do numbers 9 and 10. That'll be it for this video. Solve log base 27 of n equals 1/3. I always start with the base, 27, to the power of 1/3 equals n. I've got a power table that I could easily use to do this, but for the sake of time, like you're taking a test, right? When you're going to be doing this, just type it in the calculator. 27 to 1/3 power is 3. So in this case, n equals 3. All right, last one, and that'll be the end of this video. Expand the logarithmic equation log base 9 of 5 times n to the 5th. Now remember, multiplication inside the parentheses turns into addition outside the parentheses. So now I'm going to have 2 log base 9s. And they're going to be separated by plus signs. These are 9s, by the way. And the question is, what goes on either side, or into either logarithm? And it's 5 times n to the 5th, so I'm going to put a 5 and an n to the 5th. And you might think you're done, but you're not, because we can simplify it further now. Since this is to the 5th power, I can move that 5 out front. So I've got log base 9 of 5, that didn't change, but now I'm going to get rid of that exponent there and move it up front. 5 log base 9 of n. And I will solve the remaining problems. It looks like there are 43 total, and I will solve those in subsequent videos. But that's all for now. If you're looking for 11 through 20, watch the next video.